Well, friends of mathematics, we're in section 105, section 5.3, and we're talking about log applications. And there are three applications that we need to be aware of. The first one is noise level, which is measured usually in decibels. And decibels are equal to 10 times the log of I over I naught. And where I stands for intensity, and this is measured in watts per centimeter squared. Now, this is neither here or there. I don't really care about this measurement, but I naught is this baseline noise, pretty much the lowest noise possible that is heard by humanity. And I think we can put a number there, but whether we have I naught or not, we can play this game and figure out how loud a sound is. Now, we have the Richter scale. This is used to measure earthquakes, and this is equal to the energy of the earthquake, I believe, divided by this baseline energy level. And then finally, we have pH scale, and this is equal to the negative log of the hydrogen concentration. And I think that's measured in moles per liter, but I'm not really that concerned about it. So let's suppose I have a 2.3 times 10 to the negative fifth mole per liter hydrogen concentration. What is the pH? And here, we're just going to be taking our formula, and we'll have the negative log of 2.3 times 10 to the negative fifth. And we can put this into our calculator to figure out what the pH is, or we can just leave it like this to have an exact answer, but we'll say negative log of 2.3 times 10 to the negative fifth, and we have a pH of 4.63 approximately. Similarly, if I told someone that we have a pH of 2, what is, let's say 2.1, what is the H plus concentration? I can say 2.1 is equal to the negative log of my hydrogen concentration. We can bring the negative over. Negative 2.1 is equal to the log of H plus. And now exponentiating on both sides, 10 to the negative 2.1 is equal to 10 to the log of H plus. And murder occurs, and I'm left with my hydrogen concentration of 10 to the negative 2.1 moles per liter. So I think in the book, they might give us what the baseline numbers for decibels and for the Richter scale are, but that's not important because what's typically going to happen here is we're going to have, let's say we have two different sounds. We'll say sound A is at 120 decibels, and sound B is, we'll say, 60 decibels. Now, many people will look at this and they will say, well, it looks like sound B is half as loud as sound A, or they'll say that sound A is twice as loud, but that's not true. That's not true. What we're going to do is we're going to investigate how many more times intense is sound A than sound B. And the way we're going to do that is we're going to say that we have the number of decibels of A, and I'm going to subtract away the number of decibels of B. And what that's going to give us is, we know that the sound A, I'm going to use this relationship, 10 log, and now we have the intensity of A divided by that benchmark sound, that's just this piece right here, minus 10 log the intensity of B divided by our exact same benchmark. At this point, we can begin looking at these numbers and begin plugging them in, that we'll have 120 minus 60 And what I'd like to do here is I'd like to somehow collapse this log into 1. And so I'm going to factor out that 10 first. 10, and I'll be left with log of intensity A over our benchmark noise minus the log of intensity B over our same benchmark noise. Now, everyone knows that we have 60 over here, but a lot of us are looking at this and say, Paul, I know what to do. I have the log of a difference of logs. I can convert that into the log of a quotient. And so we'll have 10 log intensity of A over I naught divided by the intensity of B over I naught. Fantastic. I'm going to divide by 10 on both sides. And so we'll have 6 equaling this log. But we should also think about this fraction. When I divide this fraction, that's IA over I naught divided by IB over I naught. What's going to happen? We're going to multiply by the reciprocal. We'll end up having IA over I naught times I naught over IB. And you all can see that murder is about to occur. So, when we're done reconciling this fraction, we'll have the log of the intensity of A divided by the intensity of B. And this is going to happen every single time, friends. Every single time. Whether I compare magnitudes for the Richter scale or noise levels in a different setting, this will always occur. Now let's keep going. Let's keep going here. And what I need to envision is I need to figure out how many times bigger the intensity of A is than B. So I'm going to solve for one of these. And to do that, I'm going to raise both sides to the 10. 10 to the 6th is equal to 10 to the log intensity of A over intensity of B. Murder occurs because they're inverse function, and 10 to the 6th is equal to IA over IB. We're almost done. We're almost done. And the dream here, I'm going to multiply both sides by IB. 10 to the 6th times the intensity of B is equal to the intensity of A. And this, my friends, is our relationship. We say that the intensity of A is 10 to the 6th, that's 1,000,000, times stronger than the intensity of B. And so the relationship here, we saw that the decibel levels were doubled, yes? But this did not correspond to doubling the level of intensity. You'll have lots of examples like this, and this is an incredibly common problem to see on an exam, where they give us two different outputs from some type of logarithmic function, and we have to determine how many times bigger one of the inputs is than the other. All right, friends, let's do one last log application, and suppose that an earthquake in California is 5 times stronger than one in Michigan. And I want to know how much larger is the magnitude of the California quake. So what we can remember is that the magnitude, and this is a formula that you are not required to know, is equal to the log of W over W naught, where W is the strength and M is the magnitude. And so I can say the magnitude of our Californian earthquake minus the magnitude of our Michigan earthquake is equal to the log of the strength of our California earthquake over that benchmark strength minus the log of the strength of our Michigan earthquake divided by that benchmark strength. Now, we have a relationship here written into the problem that in California, it's 5 times stronger than the one in Michigan. And so what I can do is I can replace W of CA, the strength of that, with 5 times the strength of that Michigan earthquake. So now that we have the rock, what can we do with it? I can certainly collapse these two logs, yes? And so we can say that we'll have the log of 5W of the strength of Michigan over W naught divided by the strength of Michigan divided by that benchmark value. And keep in mind, when I divide a fraction by a fraction, I'm going to multiply by the reciprocal. We'll have the log of 5 strength of Michigan over W naught times that benchmark times the strength of Michigan. And murder is going to occur everywhere except for the log of 5. And so what this lets us know is that the strength or the magnitude of the California quake is log of 5 larger than the magnitude of the Michigan quake. And we can see that because the magnitude of the California minus the magnitude of the Michigan is equal to that log 5. And so I could even rewrite that the magnitude of the California quake is equal to the magnitude of the Michigan quake plus log 5, meaning that this one is log 5 bigger than that one.